Yeah, this is Wolfgang Beck here to talk about source routing vulnerabilities in SIP home gateways. Please give him a round of applause of welcome.
So we have been here. SIP was derived from HTTP and email. You can see the from header, the to header. You can see the request line above. You can see the header parts separated from the body with a blank, and here's the body part. It looks very much like HTTP or email. Okay, this is the problem here. This is the B phone, the called phone. Phone A calls the phone B, which is cut off here. You send an invite request, you get responses back, an acknowledgement, and then you have the media stream, which is the telephony, the speech or video or any other real-time media. And at the end of the call, you send it back, and the user hangs up. This is a typical SIP network. It's a bit like email. You have SIP domains. You can query them for the SIP proxy, which is responsible for the SIP domain in the DNS. There's a mechanism called SRV record, which resembles the MX record in email. Just as in email, you can either contact directly your called party if you know the IP address, or you can ask some proxy to do this for you. And SIP is for session initiation protocol, which means that only the initial request of dialogue will go to the proxies, and then afterwards you will have the IP address of the other party, and you can exchange SIP messages directly. The main means to route SIP messages is the SIP URI, and you sometimes read the term AUR, which is simply a SIP URI you can put on your business card and which doesn't change. The mapping from the SIP AUR to the IP address is simply by doing that your phone sends a register message to a proxy which tells it, if somebody called this AUR, forward those requests to my current IP address, which is the first instance of source routing in SIP. You have the contact header, which contains your actual IP address. You can have more than one contact for a given AUR. Some thought this was a good idea, which of course made the protocol very complex because you have things like forking, which could be viewed as an application layer multicast. You send a request to one AUR, and it will be forwarded to all the contacts that have registered for this AUR. Some more terms: the SIP user agent client is simply an entity which sends a request. A SIP user agent server is somebody who receives a request and replies with a response. A user agent server, or UAS, can authenticate requests with HTTP digest, which is a simple challenge response authentication method. SIP requests can have more than one response. In the case of the invite transaction, you have the ringing, which tells, okay, you have reached the called party, but the headset is still on the hook, and you can have the final response if the user picks up the headset. One principle in SIP was to keep the core stateless. This has to do with the end-to-end design principle, which is a basic architectural principle in the internet. The IETF is very keen to keep this up. But this means you have to keep the state somewhere else. And in case of SIP, it's kept in the messages themselves. And so you have many instances of source routing in SIP. You have the wire headers, which tell the called UAS where to send the response. Because of the forking mechanisms, all the proxies in between need to be informed about the responses. So you have to have those wire headers, and so the forking can work. And in the other direction, you have the route headers and record route mechanisms. With these mechanisms, a proxy can tell the user agent client, I want to stay on the signaling path. If you have another request to send, don't send it directly to the other party, but send it to me. Another instance of source routing. Okay, I'll try with this one. Now, this is a real-world SIP network. As you can see, there's an entity called RTP relay. A VoIP presentation without voice is a bit pointless. The RTP relay is simply for NAT traversal because SIP is not very NAT friendly because of all those IP addresses that are in the messages. And the safest way to do NAT traversal is an RTP relay, which simply modifies the SIP messages. Okay, don't send your media directly to the called party, but send it to me, to my public IP address. And the called party does the same, and so the RTP relay is in the path of the media, which is usually not the case if you have plain SIP. The level of interaction between the proxy and the RTP relay differs between different SIP providers. Some do every call over the RTP relay, others only if they see, okay, the user really uses private IP addresses and there must be a NAT. It's a bit of a thing. The other thing is the PSTN gateway and no connection to other SIP domains, which would be easy, but of course the reason is money because you have termination fees in the PSTN. So the business model of today's SIP providers is using the PSTN for billing and charging for certain services, which is not the best way to do it, but you don't beat business models. So, of course, this makes it an attractive target for attackers because you can do things like premium rate and other services where you can actually make money. One problem with SIP is now when you have SIP phones on the internet, you are running an internet server, which is something not many people do. Well, here in the room, I think many people run an internet server and they know what they are doing, but in the future, everybody who has a phone will run an internet server and that might be tricky. And servers, of course, should identify their clients if it's not just anonymous content. And the RFC for SIP says just use HTTP digest, which has some gap. You can't authenticate the proxies with it. You can't authenticate the caller. A proxy can authenticate a caller, but a call party can't authenticate the proxy. This is part of the protocol, how it works with transactions. So the proxy can't do a transaction of its own. So the only thing how this could be avoided would be that every caller has a shared secret with you, which is not practicable, so nobody does this. This makes it fairly simple to fake caller IDs. You just send an invite, you set the from header to some called party you want to pretend, and the SIP phone will display this as called party. Of course, it's a bit better than in email, as you can listen to the voice and say, oh, the support man sounds differently now, and this might be fishy. And it worked for decades in the old PSTN when nobody had calling party ID, no displays on the phones. And so it's not that bad, but it's not good either. Now you can use this to make a bit of trouble in the LAN that you think is protected by your SIP access device. You simply put in the contact header some IP address inside the LAN of a box that might be vulnerable, because many boxes you have at home think they are protected from UDP traffic or other traffic by a NAT router or a firewall, and they don't have to care about security like a fridge or streaming boxes or whatever. Now what happens? You make a call and you put this contact with an unstable box inside the invite request, and some time later the called party hangs up and sends a bye, but the contact manipulates the so-called route set inside the ID So the ID won't send the request back to the attacker, but it will send it to the unstable box inside the LAN. And it will try several times until the transaction times out. Can we do the same thing with responses? It's not that easy because the ID will usually ignore the IP address. This was an early attempt to deal with the NAT problems with SIP. So the wire address is usually ignored. But there's a little known parameter called mother, which was originally introduced for multicast things, which haven't been deployed really, but they are still in the SIP stacks. And the mother parameter tells the user agent server to forward this request to the IP address mentioned here. You can't put the port number in here, which kind of limits the attack, but you can still send responses to some unstable box. You can do the same thing with media by putting the vulnerable address and port number in the codec line. This is below here, the C and the M line. And what happens is you make a call and the ID will send RTP to this unstable box instead of the attacker. I know all those attacks are not too serious if you don't have an unstable box which does bad things on RTP, but it's still something you don't want in your LAN. And another method to send requests, arbitrary requests into the LAN, is if you have a proxy functionality in your IAD, you can put route headers into this message, and the proxy will forward the request to the route mentioned here, into the IP address and port number. So you can send your specially crafted invite to some hosts in the LAN. This is an adaptation of a very old attack which was used for FTP. The idea is to force the NAT router to open holes for incoming traffic. In FTP, you have a control channel where you can open the port IP address for incoming data, and the similar thing you can do in SIP. And SIP is in some respect much easier to abuse here because it doesn't use a privileged port number. It uses port number 5060, and it looks very much like HTTP. And by sending an HTTP message through the NAT router, we might convince it that it's actually a SIP message. You put simply the JavaScript into some web page, and you trick the victim into accessing this web page, and this JavaScript is executed and sends an HTTP request to port 5060, which happens to have a method of invite, which looks like it, and perhaps the NAT router will accept it as SIP. If they don't do proper parsing, if they just look for the SIP colon or SIP 2.0 string, they will think this is SIP and will open ports for you. And you can open ports with the codec line again, and you can send UDP traffic to any host. If this doesn't work because you have a smart firewall, you can always use Flash for this, because many NAT firewalls support TCP and SIP. This is the overview, how it works. The laptop in the LAN makes a HTTP GET, gets the JavaScript, and the SIP-aware NAT sees the invite, thinks it's SIP, and opens the ports. And you can send arbitrary packets into the LAN to arbitrary addresses. When I discovered this attack, I was very proud of it until I found out that Sandro Gaussi published it already in 2009. Another good example why keeping these things in secret is not a good idea. The idea is that you authorize requests coming back from the IAD. The attack, I call the victim, talk to her or to him until the user hangs up and sends a buy to me, and I challenge this buy. And now the IAD thinks I'm the trusted SIP provider, and responds with the correct authentication response. We have the challenge, we have the response, and now we can make a dictionary offline attack. As all this HTTP digest stuff is MD5 based, you might not even need a dictionary, but can brute force this thing. I've listened to some guys yesterday who did OpenCL and CUDA stuff and MD5, and I don't know if it's in the matter of hours you can scan through the key space, or if you need days, I don't know, maybe only minutes, I have no idea, but it's a really bad attack. What can you do about it? Well, the simple thing is that you limit the SIP traffic to hosts you trust. It's not perfect, you are still vulnerable against IP spoofing. Well, spoofing, most providers prevent it by reverse path filtering. It's still doable, and because of all the source routing mechanisms, you can actually see responses even with spoofed source IP addresses. So it's not an ideal solution. You can simply ignore all IP addresses in SIP. SIP providers do this very often. We have an entity called back-to-back user agent, which simply replaces all SIP messages, IP addresses inside the SIP message with the IP address of the SIP message itself. It gets a bit tricky with RTP because you have to wait for the first RTP packet to know what port number this RTP stream has, which leaves you a small window of attack open. If an attacker sends an RTP message in this small window, you can trick a back-to-back user agent into redirecting RTP traffic to yourself. Back-to-back user agents are not that loved in the SIP community or in the IETF because they go against the end-to-end principle. With SIP, you have the worst of both worlds. You have the huge messages, and you have stateful architectures. With a SIP proxy, you have very little state in the network. The SIP proxy can go down or get back up, and you won't even notice. When a back-to-back user agent goes down, you notice it. Another thing is TLS. The idea is to protect all signaling traffic with a TLS connection. So you can simply ignore all messages that don't come over this connection. It works with NAT, solves many problems. And the point with it, it's TCP, so failover isn't that easy anymore, and it requires significantly more hardware. I've questioned this, but all the vendors we've talked to said, okay, you need twice the number of boxes, and that was it about TLS. Other countermeasure is IPSec. Problem is deploying IPSec is a headache. If you have NATs, if you have different operating systems and you have to provide configurations or VPN clients to all of them, it's going to be very difficult to get this right. And again, you need hardware to do this. It's used in 3GPP IMS, which is a SIP architecture designed for mobile. But they're doing a bit more than simply doing IPSec. They are pushing all this authentication functions to the IPSec layer. Only the initial register is really authenticated with a SIP method, and they're using some SIM card mechanism here. And after that, everything runs over an IPSec connection, and every request, if it comes from the IPSec connection, it's authenticated. This has some advantages, that the battery lifetime will be better because you don't have these 401 authentication round trips. But it's nice for the mobile space, but I don't think it's feasible in the typical fixed line environment where you have NAT routers and more than one SIP phone or SIP client behind the NAT or inside the NAT. This was my presentation. Any questions?
If you have any questions, please raise your hand and I'll come to you with the mic.
Are any of these attacks already seen in the wild?
No.
Thank you.
Hi. I really like the idea of using JavaScript to make an HTTP request with an STB which opens a port. So have you really seen NAT devices which can be fooled with this kind of attack?
I've looked into the Linux kernel and I didn't test it, but they don't do proper parsing, they just look for the strings, so I think it's vulnerable.
So that's another reason why all this application layer gatewaying sucks.
Turn them off.
Does this mean this also happens from the reply from a web server? Because from Linux, if they just scan for the string and they are not checking port numbers, for example, and it's TCP zip, this could really be misunderstood as zip from some...
well, they look at the port number, but you can say, you can use the JavaScript to send something to port 5060, to the SIP port.
So it has to be the SIP port?
Yeah.
Okay.
And you have the web server under your control, which can reply to 5060 or anything else. And some web browsers probe with an option request if the SIP server actually accepts an invite method, for example. But if it's your web server, you can tell it to do so.
Yes, hi. Connecting to the SIP server with the JavaScript, I don't understand. From browser, it will not allow to, because of the same domain policy. That's first. And second, the SIP is using UDP, and the browser will also not allow connecting to UDP port. So is there any demo that can show this? Because
I have no demo ready, but I have a server, I can set up a server. The same origin policy is no problem because your web link goes to HTTP attacker server .5060. So
okay, but then
what Mozilla blocks a few ports. Mozilla blocks all ports below 1024, but it doesn't block 5060.
Yes, I understand. But still, it will not allow connecting to UDP ports.
You can run SIP over TCP, no problem. And the Linux kernel, as I read from the comments, I haven't tested it yet, supports SIP over TCP.
Okay, then you will get an effect for one browser to connect to your SIP server.
The attack is that the NAT router opens port for incoming RTP traffic, which is not really RTP traffic, but my evil packet that I want to do inside.
Yes, I would like to see a demo. Thank you.
Can talk about this.
Are there any more questions? Are there any questions from IRC, Mission Angel? Also no? Well, thank you very much. Let's give our speaker another round of applause.